This lesson we're going to look at evaluating some of the parts of a circle when we're calculating in radians. So we've done things like circumference of a circle and area of a circle previously. What we're going to start looking at now is length of an arc and the area of a sector of a circle when we're calculating in radians. And this year, your HSC, you've got your formula sheet. So these aren't formulas you need to memorize anymore. The first one you can see here is length of an arc. So remember, when we're talking about the length of an arc, what we're talking about is just part of a circle and wanting to know how big or how long is that length. Okay, so in question one, and you can see there your formula for the length of an arc is the radius times theta, remembering that theta is now measured in radians. So this isn't degrees, this is radians. Okay, so in question one, what is the length of an arc subtending a right angle at the center of a circle of radius 200 centimeters? Now this all sounds really complicated, but it's not particularly. They want to know what the length of the arc is, so they want that distance around the outside. And when it says subtending a right angle at the center, what that means is that if you draw the line to the center of the circle like this, subtending a right angle means that you're going to end up with a right angle in there. And excuse my dodgy drawing, but they just want to know what the length of that arc is if this radius here is 200 centimeters. Okay, so what you do is you take your formula, which is on your formula sheet, and it's the radius times the angle, but your angle has to be in radians. So if it's a right angle, 90 degrees is equal to pi over 2 radians. Okay, so that's the first thing. You can't just do your radius times the angle in degrees, it has to be in radians. So once we know that it's pi over 2, it's just a straight substitution into your formula. So your arc length is your radius times the angle. Our radius is 200 centimeters and the arc length is pi over 2. So the length we're looking for here is 100 pi centimeters. Now, unless they say, estimate it to 2 decimal places or something like that, you want to leave your answer in radians. There should be pi's in these answers because that's the exact answer. We're not rounding off or estimating here. Okay, now they can turn it around and they can ask us the other way. So what is the radius of a circle in which an arc length of 5 meters subtends an angle of 120 degrees? So again, just a little sketch can sometimes help you figure out exactly what it is you're trying to work out here. We're being told we've got a 120 degree angle, and again, excuse my dodgy drawing, and our arc length here is 5 meters, and they want to know what this radius is. Okay, so start off with your formula again. Your arc length equals the radius times theta. So our arc length is 5. We don't know what our radius is, and we need to work out what is that angle. So remembering that to work out what angles are from degrees to radians, we need to multiply the degrees, the 120 degrees, by pi over 180. So that's going to end up with, when you cancel it out, 2 pi over 3. So an angle of 120 degrees is 2 pi over 3 radians. So that's what I need to substitute in over here. So 2 pi over 3. So then to work out r, you're just going to divide by 2 pi on 3. So 5 divided by 2 pi on 3, you end up with 15 over 2 pi is equal to the radius. Okay? Now, if you were asked to give that to 2 decimal places or something like that, you type that into your calculator, you end up with 2.38732, etc., which rounds off to 2.39 to 2 decimal places. Sorry, that should be meters, not centimeters. Okay, so that's how we work with the length of an arc. Another part of the circle that we may be asked to work with is the area of a sector. So hopefully we all remember what a sector is. If you've got your circle, then a sector is like your piece of pizza. Okay, and again, you now have a formula on your formula sheet for this. So the area of a sector is pi r squared theta. Again, theta is in radians. Okay, so in question 3, what is the area of a sector subtending an angle of 45 degrees at the centre of a circle of radius 40 metres? So, like we've said, the sketches are a good idea. We know that this is going to be a 40 metre radius. We know that the angle in there is 45 degrees. So we've got to change our 45 degrees to radians. So to work that out, to work out what theta is going to be, we're going to multiply it by pi over 180. Okay, so once you do that, you get pi over 4. Okay, so then we're just substituting into our formula. So area is half r squared theta. Okay, which is a half times our radius is 40 and our theta is pi over 4. So then you're going to simplify all that. You just do the numbers part of it. Half times 40 squared over 4, you end up with 200 pi. Then we're talking about area, and it's in meters, so this is meters squared. Okay, and like before, if you were asked to find the radius and then we're given you the area, you would substitute in for the area, and then you would divide by the half theta. That's what you need to be able to do exercise 5.3 and 5.4. Do a few from each. Make sure that you're comfortable working both ways though. So do questions where you're asked to find the length and questions where you're asked to find the radius. Good luck, I'll see you in class.